Assalamualaikum and good morning to Dr. Hasina and friends. So we are from group 2. Today we want to present about zeolites. My name is Norani Zulaika binti Zainuddin and our group members are Nordini, Siti Nozul Hafiza, Nor Izzati and Nurul Zulaika. So what is zeolite? Zeolites are three-dimensional microporous crystalline solid with well-defined structure that made of silicon, aluminium and oxygen that form a framework with cavities and channels inside. Basically, its structure is an open 3D framework structure that built of silicate and aluminate that are tetrahedral linked to each other by sharing all the oxygen atoms. So the overall structure is known as crystalline aluminosilicates. Zeolite also often referred to as molecular sieve. Molecular sieve is a material with pores that is very small holes of uniform size. Um, so large molecule cannot enter or be absorbed while smaller molecules can. So these are the structure of the zeolites, and this is a molecular structure. And as we can see, there is a porous structure of the zeolites, and this porous site can be host to water molecules and ions such as potassium and calcium, as well as any other positively charged ion, as long as it can be fit into the pores. So the ones that can be fit into the pores can create a sieving property. So that's what I mean by the molecular sieving of the zeolite. And also we can see a tetrahedral link between the silicate and aluminate by the sharing of the oxygens. And this is what make an open framework of the pores and cavities that make it accessible for the small molecule to penetrate the zeolite channels. And this is a clear version of the zeolite structure or the 3D structure. It looks like a honeycomb, and we can clearly see the pores and also the cavities of the zeolite structure. So that's all from me. My friend Dini will continue with zeolite chemistry.
Now we proceed on the basic zeolite chemistry. As what Anis has explained before about the zeolite structure, we can see that zeolites are hydrated aluminosilicate minerals made from interlinked tetrahedra of alumina and silica. The regular framework structure contains linkages, cavities or channels which are big enough to accommodate wide variety of cations. The alumina silicate framework is negatively charged, and that's why it attracts the positive cations that reside in the cages to compensate negative charge of the framework. The cages, cavities or pores are occupied by cations and water molecules. The common positive cations are from alkali or alkaline earth metals such as sodium, potassium and magnesium. Here you can see the general chemical composition of a zeolite. M here refer to the cation metals, and here refer to the charge of the cation metals. If we use sodium as the cation metals, so the value of N here is 1. X in front of silicon dioxide refer to the number of moles of silicon dioxide molecules. It shows the ratio of silica to alumina. And Y here refer to the number of water molecules. The special aspect of this structure is that the water moves freely in and out of these pores, but the zeolite's framework remains rigid. Heat causes zeolites to let go of their water molecules and pick up other molecules from the environment through the process of adsorption. Zeolites have a high capacity for adsorption. Adsorption here means the process by which molecules bind to a surface. There are two types of zeolite. We have natural zeolites and synthetic zeolites. Synthetic zeolites are manufactured from energy-consuming chemicals, while naturals are processed from natural ore bodies. Here you can see the difference between naturals and synthetic zeolites. Natural zeolites is non-porous, while synthetic zeolites is porous. Natural zeolites do not break down in a mildly acid environment, while synthetic zeolites break down in a mildly acid environment. That shows that natural zeolites has a more acid resistant to hold its structure together compared to synthetic zeolites. That's why natural zeolites are broadly accepted for use in the agricultural industry. Here is the table for some of the common mineral zeolites. We have andesite, jebezite, clinoptilolites, morganites, naturalites, and many more. Clinoptilolites is the examples of natural zeolites which are being used in the agricultural industry as soil amendment and feed additives. Next, I will pass to Fiza for further explanation of zeolites.
Okay, for the synthesis of zeolite, so crystalline solid state material production can be classified into two groups, which is there are those who reaction occur in solid state and those who reaction occur in the liquid state. So basically, the solid state reaction occur often temperature above 300 Celsius as to overcome the difficulty that arise from the transportation of the reactant to the sites where the reaction take place. While for the liquid phase, basically it use solvent, so in the presence of solvent, so it easier for the transportation of molecule as it's occur in the lower temperature, which is lower than 300 Celsius. So the synthesis of zeolites are carried out in the liquid phase. So here are the three methods that been used to carry out the zeolite in the liquid phase. First is hydrothermal, the second one is solvent thermal method, and the last one is ionothermal method. So basically, for the hydrothermal method, is the earliest method that been used to synthesize of zeolite, which is water as a solvent, base solution as mineralizer. So these two reactants or the reactants are usually occur in the temperature of range 90 to 180 Celsius with the pressure of 15 bar inside the Teflon line inclined autoclave. So basically this method will produce an optimum zeolite production. So roughly this method is much easier and cheaper than the other method because it use low temperature. The second one is solvent thermal method. So basically, solvent thermal method of zeolite synthesis involve the use of solvent to produce zeolite. So basically, it use various type of solvent depends on the suitability. So basically, the solvent that we use is non-polar, polar, and also hydrophobic and the hydrophilic solvent. Okay, and the last one is ionothermal method, which is another special category of solvent thermal synthesis method in production of zeolite, which the solvent used is ionic compound and not a molecule and not a molecular in nature, as the solvent used are called ionic liquid, as it have their ionic nature that has effect on some particular properties such as a low vapor pressure.
Okay, my name is Siti Najul Hafiza binti Zulkifli. My matric number is 19042 and I'm going to proceed with properties of zeolite. So there are four properties of zeolite, which is the first one is it is flexible and adaptable, and the second one it is a good adsorbent. The third one it is a good ion exchangers, and the fourth one is it is good molecular sieves. So for the first one, zeolite is flexible and adaptable because of its biological activity that could be either positive or negative, and it is very suitable for some medical uses due to its biochemical process that occur through ion exchange, adsorption, and catalysis. Example of medical uses in industry is the treatment of cancer. And then the second one is it is a good adsorbent. We use these properties of zeolite in the purification of water because zeolite is very good in absorb molecules like water, ammonium, hydrogen sulfide, nitrogen oxide, nitrogen dioxide, sulfur dioxide, and carbon dioxide. And then it exploit in the enhancement of the formation of sludge, um, which is during the biological treatment stage, an increase of biological activity, which is the oxygen consumption by the living sludge, can be achieved based on the adherence of bacteria to small zeolite rock grains. The bacteria require more sludge formation adsorbed on the zeolite surface, and it results in an increased rate of settling. Hence, it's speeding up the sludge formation activity. And it also was used in treatment of drinking water, which is the presence of zeolites help in easily dewater the sludge. And then the third one is zeolite as ion exchanger. These ion exchanger properties was used in purification of water as well. The exchangeable zeolite surface ion are replaced by the ion from the solution. As for example, the solution is water. And then it has a function as boosted acid in catalytic reaction, which is it enables the catalysis process. As we all know, boosted acid means that it has tendency to give up proton. And then the last one is it is a good molecular sieve. It is called as molecular sieve because of its ability in result in high volume when heating or dehydrating the zeolite. It allows only certain size molecules to pass the entry channel. This is why we call it as good molecular sieve. And from these properties, zeolite is extensively employed in industry, which are, for example, in the separation of straight chain hydrocarbons from branched chain hydrocarbons, and next in chemical sensor in industrial process control, and environmental and indoor air quality monitoring, effluent and auto exhaust control, medical monitoring, air separation, and removal of heavy metal. So that's all for the properties of zeolite.
Assalamualaikum and hi everyone. I'm Izati. So today I will continue our slide presentation with the applications of the zeolite. So the application of zeolites for our slide is about selective adsorbents and also as drying agents. Before I go further, let's focus on the meaning of adsorption. Adsorption is the physical separation process occur when liquids, gases, colloids, and suspended matters adhere to the surface of any internal pores of a medium. So in this slide, the mediums refer to the zeolite. For the selective adsorbents, the applications that I want to stress is about the removal of metal cations from waste. So how does this thing work? It works because zeolite naturally occur as hydrated aluminum silicate mineral, which known as tetrasilicate. It has 3D structure, which is tetrahedra of silicate and aluminate. The aluminum ion is small enough to occupy the position in the center of the tetrahedron of 4 oxygen atoms. The isomorphous replacement of silicon ion by aluminum ion produces a negative charge in the lattice, in the structure of the molecule. So the net negative charge is balanced by the exchangeable cation such as sodium, potassium, calcium, and so on. Because the zeolite exchangeable ions are harmless, it makes them particularly soluble for removing undesirable heavy metal ions from industrial effluent water or the wastewater. As a drying agent, the dehydrated zeolites will be mixed with the product particles, lead to the drying of the product. Zeolite decrease in relative humidity of the environment and also increase the temperature. By decreasing the relative humidity, it will increase the drying process. The decrease in humidity is due to the absorption heat released by the zeolite. The degree of drying or the process of drying depends on the zeolite absorption capacity. So these are the reference that we use for our slides. You can refer to them for further information. So that's all for me. Thank you.